In the Arduino Uno, we can only simulate the effect of an analog signal on a device like a motor or an LED by using pulse width modulation. If we need to create a true analog signal with the Arduino Uno, we must use an external digital to analog converter module. True digital to analog conversion is the ability to convert a number to a voltage. The Arduino Zero has one pin capable of this type of conversion. In this lecture, I'll show you how to use the digital to analog converter in the Arduino Zero. Let's have a look. Hi, in this lecture, I'll demonstrate the capabilities of Arduino Zero's true analog out pin. The SUMD microcontroller has one pin with the ability to convert digital to a true analog signal, and on the Arduino Zero that is escaped to analog pin 0, this one here. I'm going to connect my oscilloscope to analog pin 0, just like that, and just have a look at the analog write instruction first in the documentation. You're probably familiar with analog write from the way that we use it in the Arduino Uno or other Arduinos when we use their PWM output capability. And the Arduino Duo, just like the Arduino Zero, has got a pin where the same analog write instruction, instead of generating a PWM signal, it generates a true analog signal. So there's no need to learn a new instruction. We're just going to use analog write, and because we are using analog write on analog pin 0, what we'll get is a true analog signal, as I said, instead of a PWM signal. Let's have a look at the demo sketch. So in this example sketch, I'm going to run it in two different configurations in this lecture. In the first one, I'm simply going to be using the analog pin 0 to output a true analog value out. And the way to do this is first, in the setup method, I specify the write resolution. In this case, I set it to 10 bits. Just go back to the documentation for a second and let's have a look at the documentation for the analog write resolution instruction. We can use the analog write resolution instruction to set the resolution for the digital to analog converter. On the Arduino Zero, the default is 10 bits. You can actually set it to a value lower than that if you want to. You just need to notice this little paragraph here that says that if you set analog write resolution to a value lower than your board's capabilities, then the missing bits will be padded with zeros. But you still will be able to change the resolution to something lower if you need to. Alright, let's have a look at the rest of the sketch. Inside the loop, so first I do an analog write to analog pin 0, and I just send out a 0 to start at a low level, and then I go in a loop and I count between 0 and 1022 for the PWM value, and then I use the analog write instruction to write a true voltage, not PWM this time, but just true voltage at analog pin 0. And then I do the same thing but in reverse in the second loop, and again I finish with a low. And this is going to create a triangular waveform. So let's upload the sketch and see the waveform on the oscilloscope. Alright, so you can see first how the value goes up and down. It's not really a digital signal anymore. I don't see the highs and the lows. It's just true voltage that is increasing and decreasing. And to get a better look at this, I can change the horizontal axis on my oscilloscope to a much bigger value. Let's make it 1 second. Alright, 1 second. And let's have a look at the waveform constructed. There you go. So once the oscilloscope got enough samples, it started creating the waveform on the screen, and that's what this triangular waveform looks like. It's a big difference to what a PWM waveform looks like. It's digital. This one is pure analog signal. I can experiment with resolution, and I can make that resolution, let's say, make it 4 bits. At 4 bits of resolution, I don't have 1023 values anymore. I have 16 values, so I'm going to put a 16 here and a 15 here, and I'd like that to be equal to 0 as well. What does that look like? So I need to change the time scale again because I've got a lot less samples. So now it looks like this. So you can see the individual steps, voltage steps, that the digital to analog converter is creating. Each one of these dots is just 1 voltage step out of 16. So I get 16 in total that make up one side of my triangle. Okay, I'll put my resolution back to 10 bits and 10, and then try something else. Now I'm going to connect the potentiometer. I'm going to plug the potentiometer to analog pin 1 to get a reading, and say one side is going to go to ground and the other is going to go to the 3.3 volt pin on the Arduino. And what I'd like to do is to be able to use the potentiometer and then do a sampling of the value of the potentiometer, and then write an equivalent voltage, true voltage, on analog pin 0. So in my sketch I set the analog read resolution for pin 1 to 12, and I've already set analog pin 1 to an input and its resolution to 12 bits. I will uncomment these lines and comment out the rest of the sketch. So down to here, and upload the sketch. Okay, so let's have a look now. I'm going to change the horizontal resolution to 1 second because okay, like that, because now my resolution for the analog pin 0 is 10 bits. Alright, so you can see as I'm changing the value read by analog pin 1, controlled by the potentiometer, the value that I see on the oscilloscope also changes. There you go. So this is true analog out on the Arduino 0. This is an interesting feature on the Arduino 0. With a true analog out, you can do things like actually play music. So you can have music or sound or speech recorded on something like an SD card or an external memory, and then you can read the music from the file and then play it through a speaker. In the next lecture, actually, I'll show you how to use your Arduino 0 in order to create 3 different types of waveforms.